Good afternoon, class. Thank you. You can sit down. All right, in today's lesson, we are continuing with the exercise on bearings that we did not complete last lesson. We have questions 6 to 10 to complete, and you've been asked to work in groups and to do the questions in groups as well. So you'll be asked to come and go through the answers on the board. So group 1 is doing question 6, group 2 question 7, and so on. After that, we are going to do a bit of revision on what we have done, and that's what this is for. If you get a question, there's 5 questions. If you get a question right, you get this. You are allowed to share it with your friends. Okay, but first of all, question 6. Group 1, please, can you come? Group 1, whoever is coming to do the question. Is anyone coming from group 1, or should we start from group 2? Group 1, come on, move. Did I explain question 6 a bit last lesson? Yes, I did, so it should be easy. Come on, someone from group 1. Come.
Question 6, we were to calculate how far the aircraft is from the line AB, and in what direction it should then fly to reach B. The aircraft is here and then it flies, I think, somewhere up here. So to find X here, we use sine 18, times that by 18, we got 24.72 kilometers. Then to find the C here, we use Pythagoras theorem, where we got 76 kilometers. So to find Y, we minus 76 from 140 to get 64 kilometers. So we use tangent 64 over 24.72, which is this one here. We got 68.9 degrees, which is this angle here. The direction you should fly to reach B, because the plane is here, is 68.9 degrees plus 270, since 90 times 3 is 270, we get 338.9 degrees.
Give her a clap. She's done very well. Okay, you all agree with the answer? And note the bearing is measured from this line, 270 plus 68.9. Very well done, Miguel. Group 2, just put yours on this side and explain it. Group 2, anyone coming for group 2? Question 7. You can use the pointer. If you can read the question.
Question
Please.
7 reads X and Y are two lighthouses, Y being 20 kilometers due east of X, which is this, from a ship due south of X, and the bearing of Y was 55 degrees. So the question is, find the distance of the ship from Y, this distance A. We use sine 55 degrees equals 20 kilometers over this. To find A is 24.4 kilometers. And to find the distance B, we use tan 55 degrees, which is 20 over
B.
Opposite over adjacent B. 20 to find B, 20 over tan 55, and the distance B is 14 kilometers.
Good. Well done, Patrick. Thank you. Anything that you don't understand from the answer? Okay. Question 8, group 3. Group 3. Who's in group 3? Did you complete the question? Not yet. Okay, group 4. We'll go to question 9 while group 3 is still working on this. Read the question first. It's on the screen.
The question reads, a boat sails 10 kilometers from a harbor H on a bearing of south 30 degrees east.
Where's your diagram?
This one. It then sails 15 kilometers on a bearing of north 20 degrees east.
And then flies bearing of 40.
The first question says, how far is the boat from H?
65 and then 40.
So,
yeah.
First, to find how far the boat is from H,
Come, give me a pencil. You draw a right angle here.
we use the figures to draw a right angle triangle, two right angle triangles actually. So sine 50 degrees is equal to opposite x over hypotenuse 10. So this x is 7.7 kilometers. Then we use the Pythagoras theorem to find this distance y. The square root of 10 squared minus 7.7 squared is the square root of 41.3244. Y is 6.428. So the distance is 15 kilometers. We subtract 6.428 and we get 8.57 kilometers, which is this length. To find the distance, we use Pythagoras theorem, so it's the square root of 8.57 squared plus 7.7 squared, the square root of 132.148. The distance from H, which is also the hypotenuse, is 11.5 kilometers. The second question says, what is its bearing from H? So we have to find this bearing. So we use sine theta is equal to 6.43 Sine theta is this angle here, 6.43 over the hypotenuse 10 kilometer. So we get 0.643, which is 40 degrees is this angle. Also sine theta, we use it in this situation, is opposite 8.57 kilometer over the hypotenuse 11.5 kilometer. We get sine theta is equal to 0.745. We convert it, it will become sine theta is equal to 48.2 degrees. So that's this angle. Okay, we use this triangle here. This is 30, therefore making this angle here 60 degrees. So 60 degrees subtract from 40 degrees, we get 20 degrees, which is this angle here. And we know that this angle here is equal to 48.2 degrees. So 48.2 degrees minus 20 degrees, as we found out from subtracting 60 from 40, is we get 28.2 degrees, which is this angle. 28.2 degrees, we subtract it from 90 degrees, we get 61.8 degrees, which is this angle. So we say the bearing of H to the boat is not 61.8 degrees east.
Any questions on Ponrilay's answer? Thank you, Ponrilay. Well done. No? Okay. Number 10. We'll go to number 10 first, and then we'll come back to question 8 and see if group 3 have done it. Who's coming for group 5? Anyone for group 5? Come. Come. I'll help you. Come.
Question 10. First, it's asking us calculate the distance of D from A. Before we find the distance of D from A, we have to find the perpendicular height first. So H is equals to, we use Pythagoras theorem to find the perpendicular height. H, cube root of H is equals to 10 squared, which is BD, minus 16 on 2 squared, which is from ear to ear, that's 8. So 100 minus 64 is equal to 36. Cube root of 36 is equals to 6 kilometers. So the height is 6 kilometers. Okay, to find x, we also use Pythagoras theorem. That's h squared minus 6 plus 8, which is 14. 6 squared plus 14 squared is equals to 15.23 kilometers.
Next, it's asking us to find the bearing from bearing of D from A. So we have to find this. Okay, we just drew an imaginary line here. So we find angle theta and minus it from 90 to get the bearing. Okay, we came up with this formula, which is bearing equals 90 degrees minus angle theta, this 10 theta minus equals 6 on 14, which is opposite of our adjacent. We came up with 90 minus 23.2 degrees, and the answer is 60. The bearing is 66.8 degrees.
Good. Thank you, Geno and Margaret. Well done. Any questions on that? You all agree with the explanation? Okay, bring it, I'll explain it. Okay, question 8 reads, an aircraft flies 50 kilometers from an aerodrome A. So this is A. And it's on a bearing of 65 degrees. Okay, this is 65 degrees from here to here. Okay, that's 65 degrees. From here to here is 50 kilometers. Okay, and then from there it flies 80 kilometers on a bearing of 40 degrees. So from here it flies on a bearing of 40 degrees. So this would be the north line. A bearing of 40 degrees is this line, which is smaller than 50 degrees. So they've actually done a good diagram, and this line must be longer than 50 kilometers. So the diagram is correct. It says find the distance of the aircraft from A and also its bearing from A. So we have to find the distance from A to this point. So let me just call this point B. Okay, to find the distance, this is not a right angle triangle. I have to come up with right angle triangles either inside this triangle or outside. Okay, there are two ways I can, from this line I can draw line this way and make right angle triangle. So otherwise outside, I see that for me to do it outside is easier. So what I will do is I will draw this triangle outside. Because if I can find the distance from here to here and the distance from here to here, I can use Pythagoras theorem to now find the distance from A to B. Okay, to find this distance, I need to put another right angle triangle inside. Okay, so I'm going to draw a right angle triangle here and a right angle triangle here. Okay, to find this length, which I will call y, and this length, which I will call x, this is also x. And if I can call this distance b, this one is also b, and I will call this one a. So to find, all right, to find y, I know that this is the hypotenuse of the triangle, it's 80 kilometers, and if this bearing here is 40, this angle is 50 degrees. So I am going to use sine of 50 degrees. Okay, you'll have to help me calculate the sine of 50 degrees is equal to y over 80. Okay, what is y? 61 point? Okay, 61.3 to 1 decimal place. Then I have to find b. This time I'm going to use cos. Cos of 50 degrees is equal to b over 80 B is equal to 80 multiplied by cos of 50, which is 51.4 kilometers. Okay, now I want A and X. So if this angle is 50 degrees, this one is going to be 25, this angle here. So I'm going to use sine of 25, which is equal to X over 50. Okay, quickly give me the value for X. 21.1. Okay, I use cos of 25 is equal to A over 50, and A is equal to 40.3. Okay, now I want distance A, B. Okay, I have to add X and Y to give me this. So X is 61.3, sorry, X is 21.1 and Y is 61.3, which is 82.4. So the square root of, because AB is the hypotenuse of this triangle. So that is 82.4 squared plus 51.4 plus 45.3 is 96.7. Okay, do that for me. Square this, add, and then find the square root of the sum. 127 to the nearest whole number. Okay. But is that understood by everybody, what you're supposed to do? Okay, now I'll find the bearing. Okay, if you look at the diagram, sorry, it's not a very big one, but if you look at the diagram, the angle 65 is this one. The bearing of this point from A will have to be this. Look at the black lines from the north direction to this line. So all I need to do is to remove this angle from 65 degrees and it will give me the bearing. But I cannot do that unless I know this angle. Okay, this one is 25 degrees because the blue one here is 65. If I, sorry, wrong. This is the one we need to remove from 65 to get the bearing. So please just note, this one is not included in 25 degrees. 25 degrees is, if I can just put arrows from here to here. But I can find the whole angle because that angle is actually an angle in this triangle. Can you see that? Okay. So what am I going to do? We know that this one is 82.4 and this one is 96.7. How can I calculate this angle here that includes this 25 degrees? What do I need to use? Sine, cos, or tan? Tan, okay. Tan of, I will call it theta, is equal to x plus y, which is not 51.4, but is it 96.7? 82.4, sorry. Okay, 82.4 divided by 96.7. Okay, please calculate that angle for me. Kyle, give me the answer, please.
.4 degrees.
All agree? 40.4 degrees? Okay. I have to take away 25, which is this angle, from 40.5. That will give me the angle I've indicated in red. And then I have to take that one away from 65 to give me this angle, which is what we want. Okay, this is the bearing that we want. Okay, so 40.4, take away 25, what do I get? 15.4 degrees, the bearing from A is 65, take away 15.4, which is 14.6. Oh, sorry. Zero for 9.6 degrees is the bearing from A, from this point to this point. Okay, is that clear now? So that's what you have to do. The question that Pondrelay did, which is question 9, is a question that is similar to that. It's not a right angle triangle that is formed, but you have to either draw right angle triangles inside the triangle that's already there, or you can draw them outside and then use those right angle triangles to calculate. When you're in year 12, maybe we'll start it this year, I don't know, you will actually be taught rules that will enable you to calculate lengths of triangles that are not right angle triangles, because we'll be looking at the trig ratios of angles greater than 90 degrees. Okay. I want every one of you to close your exercise books, please. Okay, we are going to just preview what we have done so far in trigonometry, because the next thing we will look at is solid trig, which is trigonometry with three-dimensional diagrams. And that's the last part in trig. After that, you do the test. Okay, so all books closed. If you get the first question right, you get a biscuit. And the first person that stands up is the first person that I will ask to give the answer. Let me just remove this. Okay, first question. What are the three trigonometric ratios that we have looked at? Yes, Pondrelay.
Sine, cosine, and tangent.
Very good. Sine, cosine, and tangent. Catch. Okay, next question. What are the exact trig ratios for 30 degrees? No looking into your exercise books, please. You have to tell me sine of 30, cos of 30, and tan of 30. Exact ratios, not looking into your exercise books. You're supposed to memorize that. Gabriel, are you standing or? If not, two people can decide and then they can share the biscuit. Quickly. I'll give you a hint. I'll give you one. Sine 30 is a half. What's cos 30? Cos 30 and tan 30. Kyle? Okay, Kyle has the answer. Stand up and give us the answers.
Sin 30 half, cos 30 1 over root 2, and tan 30 root 3 over 2.
No, you've got them the other way around. Anyone else? Nobody answered this one. Come on, give it a try. Okay, sine 30 is a half, cos 30 is root 3 on 2, and tan 30 is 1 over root 3. Next one. What are the exact trig ratios for 60 degrees? That's easy because I've told you the trig ratios for 30 degrees. They are related. Sine of 60, tan of, cos of 60, and tan of 30. Sorry, tan of 60, sorry. Daniel, pass the mic to Daniel.
Sine is root 3 over 2, cos is half, and tan is root 3.
Well done. They are very similar to trig ratios for catch. You have 2 more questions. Question 5. What is the difference between the angle of elevation and the angle of depression? Quick. Or give me the definition of the angle of elevation and the definition of the angle of depression. If you want to come and draw it on the board and just explain it, you can. Patrick, do you put your hand up? Okay, what's the angle of elevation? One person stand up and give me the definition of the angle of elevation. Solomon, pass the mic to Solomon.
The angle formed between the horizontal and the line of sight.
Where's the
going up.
horizontal?
Horizontal ground level.
Okay, at the bottom. Right, what about the angle of depression? Anyone to give us the angle of depression? The definition? If you heard the definition that he gave, there's only one thing that's different. Come on. Andrew. Miriam. Miriam's got the answer. Give the mic to her. Pass the mic.
For angle of depression, the level of the horizontal eyesight is on top and the eyesight line goes downwards.
Okay, where is the observer?
The observer is on the top.
Okay, the observer is at the top looking down. Okay, last question. What are the 3 main points you need to remember about bearings? 1, you got to get at least 2 to get 1. Okay, Kyle. Kyle's got his hand up. First one. Okay, give chance to somebody else. Well, hurry up. We don't have the whole day. 3 things that I said. Very important. You have to get at least 2 to get the biscuit. Okay, Chakumai. 1.
It has to be 3-digit and it runs clockwise.
From?
Left to right.
From?
Right to left.
No, I don't accept right to left. From?
Not all the way.
Okay. 3rd? Okay, at least 2. It's, you use that to measure direction. Okay, that's all the questions. No more questions. Your homework, you are to do a revision exercise. Question 1, 2, 3, 4, 5, 6. And I am going to collect the exercise books to make sure you do the work. The key word for today is look. Okay, stand up. Good afternoon, class.